we're starting.
All right, so we're doing the Friedel-Crafts Alkylation of meta-xylenes, our aromatic system. So it's a meta-toluene, meta-methyltoluene, two methyl groups. We're also going to use tert-butyl chloride, right? So that's going to be our electrophile. So to start off, we're going to take a small test tube, 13 by 100, small test tube. We're going to take a pre-made pasture pipette, glass pasture pipette with a thermometer adapter. We'll have these made for you. You want to put this over the top so it should fit snugly. Before we put it on there though, we're going to add in our meta-xylenes and our chloropropane. We'll have needles ready for you to do that. So you add that in, put this over the top. Now we have a special larger test tube. We're going to take a piece of moistened cotton, so not soaking wet, but moistened. And we're going to take a piece of litmus paper because we're going to generate HCl gas as we learned throughout Friedel-Crafts alkylation. So we want to show we're generating it. So we put that over the top. You can see how it kind of snugly fits. And now the last thing we want to add is our catalyst that's going to help make that super electrophile. And that is our iron 3 chloride. Now this stuff is anhydrous, so we don't want to expose it to the air for any longer than we have to. And we're going to want to use filter paper this time, or not filter paper, whey paper, to measure this out. So we're going to measure about 45 mgs, and we're going to quickly take the top right off and pour it down. Right? And hopefully, I've missed one step. Before we do that, we should take some ice and actually have this on ice and cool it down first, because this is going to be a really strong reaction, so I want to make sure it's cooled. So we added our iron chloride. After we've cooled it down, we're going to take a little bit of parafilm at this point. We're going to want to kind of wrap this up down here at this point. We're going to kind of seal this up. Right? And then we're going to wait 30 to 45 minutes until the HCl gas no longer is evolved. So once all that's done, we want to get rid of our catalyst. And to do that, we're going to do a microfiltration. So we're actually going to we use a lot of pasture pipettes in this one, a lot of small scale stuff. We're taking 2 long pasture pipettes and just a little teeny bit of glass wool. And so what we're going to do is we need to plug the bottom here. So we put that one piece of glass wool there. We'll take the other pasture pipette and ever so slightly kind of compress it down there until it creates a little plug. And then what we're going to do is we're going to take our silica gel. Remember, the whole point of this is to get rid of our iron 3 chloride. We don't want the metal for our extraction. Take another pasture pipette. We can actually just pull up with these little yellow bunny rubbers, and we can actually put in silica gel. And you want to fill it up about halfway. And what you're going to do then, once you have it filled up halfway, and this is done, you're going to take the top off of this ever so gently, and you're going to take out your reaction mixture, and you're going to filter this through into another pipette. Right, probably be a larger test tube, excuse me, not pipette, test tube. So once you've filtered and you got rid of your iron chloride, what you need to do now is basic extraction, which we've learned a lot about. But instead of using a SEP funnel, since we're in such a small scale, we're going to do a micro extraction. We're actually going to do it in this test tube. So right here, originally, our reaction mixture is going to be organics. So that would be a top layer. And what I've done here is I've added water. And so in this reaction, first we're going to add water, and we have an organic layer and we have a water layer. So what we're going to need to do though is we need to get rid of that water layer. So to do that, we're actually going to take another pasture pipette and we're going to push the yellow bulb. So you see I pushed all the air out and I put it to the bottom because I want to get rid of the aqueous layer, which is on the bottom. And I take that and I put it into a beaker because that's where aqueous things go. I push the air out again and I can extract some more. And I keep doing this until all the water is gone. So once all the water is gone, all that's left, hopefully, purposely, is the organics. So the first time we do this, we add 1.5 mils of water, and the next time we add bicarb solution to quench any leftover HCl. So we really want to make sure we get the bottom layer out. And then once we're all done with that, we take our test tube. What we want to take now is just organics. We're going to put this into an Erlenmeyer, because that's where organics go. And we're going to use a drying agent, calcium chloride, to dry any leftover water that's in there. So we take another pipette it out of the test tube into the Erlenmeyer for the drying. We usually have to let it dry for about 5 to 10 minutes. Calcium chloride takes a little bit longer to do the drying. So once we've waited 5 to 10 minutes, now what we need to do is purify this. And the way we're going to purify this is distillation at a micro scale. So again, we're going to take out our newly dried organics and put it into a large test tube, which is in a thermal well with a sand bath. Now we're going to need to heat this up quite a bit. So we need to look up everybody needs to look up the m-xylene's boiling point. So we need to know that, because what we're going to do here is drive equilibrium. So if we make one of the starting materials, we're going to essentially take one of the starting materials out to purify it and leave behind our leftover product. So essentially at this point, we heat it up, and probably going to have to put it on your thermal well dial, probably at 4 or 5. As it's boiling, what you're going to do is you're actually going to capture the vapors of the leftover starting material and put it into a different test tube. So you literally capture the vapors, so you squeeze and you pull up the gas vapors and put them into a different test tube, leaving behind only your product purified. How do you know when you're done? Essentially you take a thermometer, and that's why you need to know the boiling point of the m-xylenes. You stick that in here and say, alright, the boiling point, whatever's boiling now is above m-xylenes. That's no longer left in there, it's just my leftover product. You're done. You can turn the heat off. It's going to take some time to let it cool down. And you should have a little bit of liquid left in there, and then you need to do your IR and NMR. And that should be essentially what we're doing today. And the last part, once we're done with this, we're actually going to use the computers and computationally figure out what product we form. That's it.